3.4 Zeros of polynomial functions preparation. Determine whether the graph of y is equal to x to the third power is symmetrical with respect to the y-axis, the x-axis, or the origin. All right, so let's try the first one, which is the y-axis. Let's see if we can do this. So y-axis, what we do is, it's kind of the opposite. So what we do is we plug in a negative x. So if y is equal to x to the, so we say negative x to the third. I put the parentheses to show the substitution. Now, if I say negative to a third power, it's still negative because that's an odd power, right? A negative times a negative times a negative is a negative. So what we end up with is negative x to the third power. And as you see, we did not get back the original equation. Okay, so that did not work. Okay, so let's try x-axis symmetry. X-axis. All right, so for the x-axis, what we do is we substitute in a negative y and see if we get back the original equation. And all that gives me is a negative y is equal to x to the third power, which again does not match the original. So that did not work either. And what we can do now is we can say, well, what about origin? Origin. Okay, so origin symmetry. Well, what we do is we plug in a negative y and we plug in a negative x and we see what happens. That gives me negative y is equal to x, negative x to the third. Now, initially, this does not equal the original one, but I can simply multiply this entire equation by a negative 1, right? Or divide everything by negative 1, flip all the signs, and what I end up with is, right, because negative 1 times negative y is positive y, negative 1 times negative x, so I'm just distributing, negative 1 times negative x to the third power is positive x to the third power, and what you see here is you get back the original equation. So this does, in fact, have origin symmetry. Okay, so let's try another one. So determine whether the graph of y to the fifth is equal to x to the third is symmetrical with respect to the y-axis, the x-axis, or the origin. By the way, if you're noticing some patterns here as to the powers of the x's and the powers of the y, or the combination of the two, there is a pattern there. There is a pattern there. Let me go over a few examples first before we get there. All right, so again, we're going to try y-axis symmetry. And what I mean is there's a pattern that will determine whether or not it has y-axis symmetry, x-axis symmetry, and origin symmetry. Okay, so we do y-axis symmetry, which means we plug in a negative x. So we keep the y to the fifth power is equal to, and we actually have a negative x to the third power. Well, negative x to the third power is equal to negative x to the third power, right? Negative times negative times negative is a negative. So we ended up with y to the fifth is equal to negative x to the third, which does not equal the original one. So this does not have y-axis symmetry. Well, what about x-axis symmetry? Well, we do the same thing, but now we have to plug in a negative y to the fifth power. Oops, it's supposed to be positive, but there we go. Positive x to the third, right? So so in x-axis symmetry, we put in the negative y, and negative y to the fifth power is negative y to the fifth power, and that is equal to x to the third power. There we go, less confusing. Okay, now this obviously does not equal the original because the original one has positive y to the fifth power is equal to positive x to the third power, and this has a negative x to the fifth power, or negative y to the fifth power in this case. So that did not equal the original, and we can't make it equal the original by multiplying or dividing both sides by a negative 1, or by flipping the signs. All right, so let's try origin symmetry. Origin symmetry. Okay, so we have to plug in both a negative y, and we have to plug in a negative x, which gives me a negative y to the fifth is equal to negative x to the third. And when I multiply everything or divide, I can divide everything by negative 1. What that gives you is y to the fifth is equal to x to the third, and that gives me you end up with y to the fifth is equal to x to the third. And since that is equivalent to the original one, we did in fact prove that it had origin symmetry. Now we can also just look at here and just kind of pick some points, right? So this point right here, we can tell what this point is and just kind of verify it graphically as well, right? So that point right there is a 2, looks like 2 out, and these are counting by half, so that would be like 1.75, right? And if we go and pick this point over here, we would see that this is in fact is a negative 2 and a negative 1.75, which just verifies what we proved algebraically, right? That if we have a negative x and a negative y, sure enough, there must be a positive version over here, and there is in fact a positive version of that point over there on the right side. So this just proves the graphical analysis that we had earlier.